because I have to discuss the module. How you are going to find out the number of modules? It depends on the how you are going to get the number of how you are going to get the current. Because to get the required current, we have to connect the modules. So the modules are going to be connected in a parallel to get you the required ampere hour. So for that purpose, I just ask you whether you are familiar with the how to calculate the number of cells and how to calculate the number of cells in series and parallel. So cells when connected in a series makes a one module. When number of modules are connected in a parallel makes a battery pack. When you are going to deal with the battery pack, then this is the outer structure of your battery pack, which consists of the casing. Either it is a metal or the plastic, but generally we are preferring for the metal casing as the IP67 no, rules are going to be there, stringent rules are going to be there. So for that purpose, it is preferable to go for the metal casing. In the pack, we are going to have the BMS, which is going to be monitor, as we already discussed in the second day by the Mr. Santosh. What is the function of the BMS? So we are going to use the BMS. We are going to use the sensors into the battery pack, connector, and cooling system to maintain the temperature of the battery within the specific region or specific temperature range. Then we have the module. Module is also going to consist of the casing, cooling system. Then we have the cell, which is the smallest entity of the battery, which consists of the anode, cathode, electrolyte, and separator. Any doubt in this slide? So that I can proceed. Can I proceed?
Yes, sir. Yes, sir.
Okay. So just these are the GI. Just go through this. The external one is the battery shell or the battery container in which you are going to keep the module. So there are the modules are going to be placed into the battery. Now in between these two modules, you have the BPMS, either air cooled or the liquid cooled. As per that, you are going to get the channels to cool the modules. Then how you are going to get the model? This is your single prismatic cell. You are going to connect the number of cells to make a model. So this one is your one model. So this one is your one model. Battery modules under that cells. And this one is the connection of the cells to make a model. So you can check it out. There are the 6 cells in a parallel which are going to be connected with the nickel plate, which with the resistance spot welding. This one is the construction. How you are going to get the cylindrical, prismatic, and the pouch cell. Okay. So if you are going to check out the construction of the cell or the construction of the lithium ion cell, cylindrical, prismatic, and pouch. Out of that, cylindrical have the maximum mechanical stand. He is easily going to be capable to get the thermal to control the thermal expansion as compared to the prismatic and pouch. In pouch, you are going to get the maximum expansion due to the gas release, and then in prismatic, you are going to get the lateral deformation or the lateral expansion during the work. In cylindrical, you are going to get the minimum expansion during the working. Any doubt up to the construction? Hello.
Yes, sir. Please.
Then we will discuss some of the basic definitions about the lithium ion battery technology. Specific energy, it is the amount of electrical energy stored for the every kilogram of battery mass, and it has a unit of watt hour per kg. Then energy density, it is the amount of electrical energy stored per cubic meter of battery volume. It has a unit of watt hour per meter cube. Then specific power and energy efficiency. Now let me know, if you are going to design any vehicle, if you are going to design any vehicle, which of the parameters you are going to consider from the specific energy, energy density, and specific power or a power density. What will be your primary criteria to decide the battery? Hello, hello, hello.
Hello, sir. Please.
Uh, my question is that when you are going to select a battery, how you are going to select, or which one is your primary concern when you are going to design or select the battery for any specific application? Suppose you are going to design or you are going to select the battery for the four wheeler, whether you are going to concentrate on the energy density or you are going to concentrate on the power density. What is the impact of it? Because specific energy watt hour per kg, energy density watt hour per meter cube. So how you are going to concentrate on it, or how you are going to correlate these terms with your battery requirement? Anyone? Based on sizes. Okay. Battery capacity. Yeah, I will share the PPT. PPT is not a big deal. We are from the academy, so for that purpose, I can easily going to share the PPT. But it will always better to interact, because as a facilitator, we have to clear the doubts. Yes, Shishupal sir. Hello, hello, hello. Shishupal sir, whether you want to say something? Okay. Now, one of the biggest hurdle to penetrate the EV into the market is the range anxiety. So you have to concentrate on the range anxiety, or you have to concentrate on the range. As a customer or as a layman, we require the higher range from the vehicle. So when you are going for the range, you have to increase the energy. Now, what is meant by energy? Energy is the integration of the power with respect to time. What is the power? Well, power is the amount of energy required to drive the vehicle with certain speed and with certain payload. So for that purpose, power we can going to fix up, but the energy as it is going to be required for to get the specific range from that battery. Now, if as we are going for the higher energy density or we are going for the higher range, we have to select a battery which have the higher energy. When we are going for the higher energy and your daily use is again on the lower side, then again there is a problem on the battery life. Because if you are going to consider, just for an example, all of you are familiar with the Tata Nexon EV. It is going to have the battery EV Max have a battery of 40 kWh. 40 kWh is going to give you the range up to 430. Now, when you are going to charge a battery, or whenever you are going to get the 430, that 430 kilometer per charge. So, whenever you are going to charge the battery 100%, you are going to get the 430 kilometer per charge. What is the meaning? That you have to travel the 430 kilometer, then you are going to charge the battery. But in a day, if I am going to drive the vehicle only for the 5 kilometer or 10 kilometer, then how much energy is going to be utilized from it? That is the one of the question. Why it is a one of the question? Because right now we are going to deal with the lithium ion battery. Lithium ion battery have the anode, cathode, electrolyte. Those are inserted into the cell, which have the 24 hours connection with it. So for that purpose, there your life is going to get detrimental. How we will discuss afterwards. But if you are not going to use it for a sufficient time or for a sufficient range, then it is again have the detrimental effect if your power is high and you are going to utilize on the lower side. So for that purpose, while selecting the battery, you have to keep the eye, or you have to optimize the result from the energy density point of view also, and from power density point of view also. So for that purpose, you have to keep the eye, or you have to keep the observation on the energy density and power density. Both are going to deal uh, with both are going to have the prominent weightage while the selection. Now, in that case, when you are going to deal with the acceleration, acceleration means within a short time you are going to accelerate the vehicle with a certain speed, or we are going to achieve the 60 kmph within a 10 second. At that time, we require the power with a higher range. So, at that time, your power density is going to be play the major role over the energy density. So, in such a way that you have to deal from both, or you have to keep your feet on the both the stones. So for that purpose, firstly, deal with the power density and energy density, then we can move ahead. Okay, any doubt up to this point? Can I proceed? Okay. Then the capacity and the depth of discharge. You can check it out. C is equal to integration of I from with respect to time, 0 to certain time. That means your current is going to be withdraw from the battery, and depending on that, your capacity is going to be there. Now, why we are only going to be concentrate on the I? Because throughout a system, your voltage is going to remain constant. Power is equal to VI, so V is going to remain constant. So for that purpose, we have to concentrate on the I. So how you are going to withdraw the I? The power is going to be withdraw from it. So now again there is a pattern to withdraw the I. If you are going to drive your vehicle at a constant speed, then your I withdrawal is a constant one. Then if you are going to move your vehicle with a linearly, then your I is going to be moved linearly. But if you are going to give the fluctuation in the speed, then there is a fluctuation is going to be occur into the I. Again, I is an important entity which you have to be concentrate from the too many point of view, because the total performance of the cell or the total performance of the battery is depending on the I. Why I? Because when you are going to say the performance of the battery means giving the output. As the temperature of the battery or as the temperature of the cell goes on change, the performance of the cell or the battery is going to be changed. Now, as the temperature goes on change, now how the temperature is going to be correlated with the I? In the battery or in the cell, when you are going to deal with the generation of the heat, then there are the four ways by which your heat is going to be get generated: during the charge, during the discharge, during the heat of polarization, and heat of reaction. Out of that, the I square, or the Joule's heat, which is going to be caused during the charging and during the discharging, is the prominent way. But in the case of charging also, when you are going to put your charger, you are going to put a constant power into it. So for that purpose, it is a constant I which are going to be put into the battery. So for that purpose, whatever the heat is going to be generated, it is a uniform heat. But at the time of discharge, as your loading pattern or your driving pattern is going to be changed, your I value is going to be changed. So Joule's heat is going to be changed. Because of that Joule's heat is going to be generated into the cell, and which is going to be cause the raise of the temperature of the cell battery. And if the temperature of the cell or the battery goes on increasing, then there is a detrimental effect on the battery performance. So for that purpose, we have to concentrate on the I. Okay? Any doubt up to this point? Or anyone want to discuss any point up to this point? Hello. Everything is clear up to this point? Why we are going to deal with the capacity, integration of the I with respect to T? Yes, anyone want to say? Okay. Then second one is the depth of discharge. Hello. Next, depth of discharge. Again, you can check it out how much you are going to left out with respect to the 100% of its capacity called as a depth of discharge. Now, generally, it is recommended that you have to go for the 80% depth of discharge. Why we are not going for the 100%? Because if you are going for the 100% depth of discharge, then there is again the thermal load is going to be get generated on the cell. So for that purpose, 100% depth of discharge is not recommended. Again, when you are going to charge, it is recommended to charge up to 80% or up to 90%, not 100%. The charging is recommended. So your working range of the battery is up to 90% charging and is up to 20% discharging. That means you are going to keep the 20% capacity into the cell. Okay. Okay. Hello. Hello. Then SOC, state of charge. The formula is simple. Amount of remaining charge divided by practical capacity of an accumulator. Even though the formula is simple, it is not a that much simple entity which is going to be carried out or which is to be taken into granted. As per the formula, it is says that amount of the remaining charge of the battery. But when you are going to say the formula, if you are going to deal with the formula, SOC is equal to capacity minus integration of the I or discharge current with respect to time. But again, it is not the linear relationship. Your SOC is too much vary as per the discharge rate, as per the rise of the temperature, and as per the change in the load or the loading condition. So for that purpose, your SOC is not the linear relationship. It is going to be depend too much on the performance or the too much on the loading conditions. Now at the bottom, you are again going to get one of the again a formula that is a SOE, that is the state of energy. We are going to correlate the SOC with the SOE. So SOE is going to say SOE is equal to energy divided by energy stored. That means energy remain into the battery divided by the energy stored, because battery is one of the type of the energy storage device. So just go through the slide. Okay, just doubt or just query, as we are going to deal with the SOC and SOE. Let me know the voltage. All of you are familiar with the uh, circuit diagram of the cell. Suppose this one is my electrochemical cell. These are the two terminal which you are going to take out the voltage. This is your E, which is the energy generated by the cell. This is the resistance. This is your I, which is flowing through it. Each cell, for your simplicity, we are going to consider it is of the 2 volt. So let me know the relationship of the V with respect to E and IR. Anyone is familiar with it? Anyone is familiar with this relation? If yes, then okay. If no, then also okay. I will discuss. At the time of discharge, V is equal to E minus IR, and at the time of charge V is equal to E plus IR. All of you are getting? E is the energy stored into the cell. I is current flow through it. Resistor is going series resistor is going to be there. So you are going to get the V is always less than the energy generated by the cell. So for that purpose, during discharge, V is equal to E minus IR, and during charge, V is equal to E plus IR. All of you are getting it? Hello? 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 Anyone is in meeting or I left the meeting?
Yes, sir.
Yes, sir.
So can I proceed or any doubt up to this point?
Proceed, sir.
Okay. So up to this point, we discussed the battery, how you are going to get the battery, then the types of the cells which you are going to be used in general, cylindrical, prismatic, pouch cell. Then we are going to discuss the basic definitions which are going to be required for the battery. Now we are going to discuss the classification. Now in front of you, you can discuss, check it out, the classification of the battery. That is your uh, primary battery, secondary battery, reserve cell, fuel cell. Okay, just go through it. Okay, so we are dealing with the first primary batteries. Primary batteries are never the chargeable. Once you use, it is gone. So it have only one life. You whatever the cells we are going to be used in our wall clock, in our wristwatch, in your remote of your TV, AC, or a DVD, that all deals with the primary batteries. Then secondary batteries, those are the reversible or the chemical reaction occur in the secondary batteries are the reversible in nature. Then third, reserve cell. Reserve cell, these are the cells, those are going to be activated as per your requirement. When you are going to say those are going to be get activated means your separator is going to be get isolated. You are going to trigger to activate the separator. So as the separator is going to be activated, the reaction is going to be continue. So it is going to be generally going to be carried out into the detonators, which are going to be acted on the water, pressure, temperature based. So it is going to be carried out so that these cells are going to be come into the picture. Again, it is only once it is going to be used, then it is not going to be used. Fuel cell fuel cell is the uh, what you say. We are going to say that it is the future of the upcoming uh, automotive
Please wait. Due to network failure or something problem is there, so we will wait for 2 to 3 minutes.
Am I audible? Hello.
Yes, sir.
And really sorry for the technical glitch. I don't know what happened. Sorry for that. Just a second. I will share. We are on this slide or we are on this slide when I lost it.
Please, presentation mode, sir.
Okay.
Your PPT is not visible, sir.
Okay, just a second. Now it is visible.
Not it, sir. Not it.
On my side, I shared the screen. Sorry, an error was has occurred when screen sharing. Now is it visible? Now is it visible?
No, sir.
I share the screen also. Sorry, has an error has occurred when screen sharing. Now it is visible. Anyone can help me out how to share because there is a issue from my on my screen. It is shows that I am sharing the screen. Screen is visible now.
Hello, sir.
Huh.
If possible, you can share your PPT with us, sir.
Just a second. I will share. Just a second. Sir, can I share on WhatsApp?
Yes, sir. Yes, sir.
Okay, just a second. Yes, sir. It is on your WhatsApp.
Receive, sir. Receive.
Just a second.
Just a minute, sir.
Yeah, no issue. Ten number slides, sir.
Siddharth, sir, please switch to PPT mode, PowerPoint presentation. Have already done, sir.
Just share it out, make it PowerPoint presentation, and then share the PowerPoint presentation. Dear all, if meanwhile if you have any type of doubt, then I am happy to discuss. So kindly, if any type of doubt in case of battery, then it will be my pleasure to discuss. Hello, no one may want to discuss. Yes.
Not working.
Okay. Okay. So hopefully we are on the classification. We are on the classification. So there are the four types of the classification of the battery. First one is the primary cell, then there is a secondary cell, then there is a reserve cell, and fourth one is the fuel cell. Primary cell, once you are going to use those cells, their life is going to be get vanished after the end of that use. So our wall clock, wristwatch cell, our remote cell, either TV remote, DVD remote, car tape, all those are under the primary battery, because whatever the reactions are going to be occur in those cells are only the irreversible reaction. That means you are not going to reverse those product into their original form. So for that purpose, it is called as a primary battery. In secondary battery, whatever the reactions are going to be occur on anode and cathode, those are going to be reversible in nature. So as you are going to apply the external power source, those reactions are going to be reversed back, and they are going to be their products are going to be get dissociate to form the original components or the original compounds on the anode and cathode. So for that purpose, it is called as a secondary battery. Reserve cell, reserve cell is different from the primary and the secondary cell. In the reserve cell, acts as a detonator. It acts as a detonator. So either with the help of temperature, either with the help of pressure, or with the help of water, we are going to activate the separator. Till the activation, your separator is totally isolated. As it is totally isolated, your ions are not going to be moved from the anode to cathode. So for that purpose, total reaction is totally stopped. So as you are going to activate it with the help of water, temperature and pressure, the separator is going to be break out from the isolation, and it is going to take care, or it is going to be taken part into the chemical reaction, and the reaction is going to be completed. These reserve cells are going to be used in the detonator purpose only. Then fourth cell, fuel cell. Currently, the fuel cell is going to be have the lot of attention, because as per our mission of the green mobility, we are going to concentrate on the fuel cell. In fuel cell, we are going to use. Please next slide. In fuel cell, we are going to be use the hydrogen as the fuel. Hydrogen is easily available into the atmosphere, which is abundantly in use. Again, we have the lot of hydrocarbons which are going to be generate the hydrogen. So for that purpose, we are going to use the hydrogen. Then after the use of that hydrogen, whatever the product is going to be generated, it is the H2O. So we are not going to contribute for the global warming or any type of deteriorated product. So for that purpose, fuel cell plays the major role. So, but right now, as the topic is restricted to the lithium ion, we are going to concentrate on the lithium ion, not on the fuel cell. Next slide. Then in next slide, we have the secondary batteries. Secondary batteries, as it is called also called as a rechargeable batteries, because the reactions are the reversible in nature. Because of that reversible nature, during the discharge, what are the components are going to be formed on the cathode, those are going to be get dissociated during the charging, and again the original form is going to be presented on the anode and cathode. Just for an example, deal with the lead acid battery. In lead acid battery, Pb and PbO2 are the anode and cathode respectively. So when the discharging is going to be occur, Pb or the lead ions are going to transfer from the anode to the cathode, and the PbSO4 is going to be get deposited on the cathode. Now, during the charging process, that PbSO4 or the lead surfactant is going to be get dissociated, and the original H2SO4 is going to be formed, and the original lead is going to be again deposited on the anode. So these are the reversible reactions are going to be occur. We will discuss that reaction afterwards also. Secondary batteries are always going to be used for the high drain application. What is the meaning of high drain application? At the start, we require the high peak current. To get that high peak current, we require the high peak power. So for that purpose, secondary batteries are capable of giving the high drain current or the high surge current. Currently, lead acid battery is predominantly going to be used where your high surge current or high peak current is going to be there. Although the initial cost of the secondary battery is too much high, you can get the primary battery into 15 rupees uh, of double A cell, but the same battery, if you are going for the rechargeable, then it's cost a lot. But if you are going to deal from the service life point of view, then service life of the rechargeable battery is too much high with compared to your normal primary cell. Now, in there, at the last sentence, there are the two subcategories of the secondary batteries. One is the load leveling, that is the stationary storage application, and second one is the or movable energy source. What is in the secondary or stationary energy source? In your lift or in your home, we are going to use the lead acid battery as a power source for the UPS. So it is called as a stationary energy source to give the power to your use as per your demand. as the weight to energy ratio or energy to weight ratio in case of lead acid is on the higher side, we are going to keep it as the stationary energy source. And in case of movable, we are going to use the lithium ion battery category for the movable energy source as the energy density is high with compared to its weight. So for that purpose, we can easily carry to generate that much energy. Okay, any doubt up to this point? Any doubt?
No, sir.
Okay. So first rechargeable battery, which is the older technology, mature technology, and till date it have the prominent dominance into the market. That is the lead acid battery. On you can easily going to check out on the left hand side there is a GIF. How you are going to work on it? There are the two electrode. One is of the lead and second one is of the lead oxide. During discharge, lead is going to be release the electron and release the lead ion, which are going to be transferred from the anode to the cathode. So on the cathode or during the transformation, the reaction of the lead is going to be occur with the H2SO4 and the lead sulfate is going to be formed, which is going to be deposited on the cathode. So at the end of the discharge or at the end of the discharge, you are going to get the lead sulfate on the cathode. So when you are going to charge that lead sulfate or you are going to give the external source of the energy, because of the external source of the energy, lead sulfate is going to be get dissociated to form the H2SO4 and that lead is again going to be transferred to the anode to form its original type. Okay, just go through the GIF and just go through the reaction. Any doubt? Yes, any doubt? Or can we move? Second, we will run fast because we have to cover the lead as lithium ion.
Please proceed, sir. Please proceed.
Yeah, nickel cadmium. In nickel cadmium, again the same reactions are going to be occur. Cadmium is going to release the electron and cadmium. Next, nickel metal hydride. In this case, metal hydride, as the name says, it is a metal, but it is the complex elements which is going to be produced. We are going to produce the AB2 and AB5 as a metal hydride, or by which we are going to make the anode. So, for that purpose, the reaction is a complex in nature. Next, now these are the just classification of the lead acid, nickel cadmium, nickel MH, and lithium ion battery. Now we will move to the lithium ion, which is the today's topic. Now this one is the lithium ion cell, GIF. Might be all of you are familiar with it. During the charge and during the discharge, how the lithium ion is going to be transferred. During discharge, lithium ion is going to be transferred through the separator to the cathode, and the electrons are going to be moved from the external circuit. Next slide. So during the discharge from the anode, all the things are going to be moved to the cathode, and during the charge from the cathode, lithium ion is going to be moved to the anode. Next slide. All GIF deals with the same. Okay. Next slide. Okay. Now the lithium lithium ion battery. It is currently have the more popular choice or the most probably going to be selected as a source of energy source for the electric vehicle. Now, when you are going to say the lithium ion battery, in the lithium ion batteries, which is going to become into the picture from the 2000th century, up to date we have the six types of the cathode which are going to be used in the lithium ion category. We start with the lithium and lithium oxide as the primary chemistry for in the lithium ion, and right now we are dealing with the LFP, NMC, NCA, LTO, such a types, where we are going to change the cathode of the lithium ion battery. Now, when you are going to say the lithium ion battery, always electrochemical cell consists of the three types, three major elements. One is the anode, second one is the cathode, then third one is the electrolyte, and fourth one is the separator. Now, if you are going to check out then all over the research, or if you are going to check out the research, then there is a dominant research is going to be occur on the type of the cathode, or we are going to change the type chemistry of the cathode. Anode, right now we are going to concentrate on the change of the anode chemistry in such a way that performance is goes on increasing. Now, when we are going to deal with the lithium ion battery, it is again the same thing, that there is an anode which is generally the lithiated carbon anode, from which we are going to release the lithium ion to the cathode. So on the cathode, the lithium ion is going to be get deposited, and the reaction is going to be get completed to generate the required EMF. Now on your screen you have an image in which on the top there is a cylindrical cell. How you are going to manufacture the lithium ion battery, then how the reactions are going to be occur, and how we are going to get it. Next slide, please. Now, just deal with this diagram. There are the two ways. One is the charging and one is the discharging. On the right hand side, there is a discharging. Firstly, concentrate on the discharging. Why we have to concentrate on the discharging? Because we need the battery in a discharging mode, because we can store the energy at anywhere location or at a stationary location, but we require the power in a movable at the time of discharge. So for that purpose we have to concentrate on the discharge mode. When you are going to concentrate on the discharge mode, your anode is a lithiated graphite anode. So lithium is going to be inserted into the graphite. So during the discharge, that lithium ion is going to be released from the anode, and it is going to be transferred through the electrolyte on the cathode. Now the cathode, if you are going to check it out, it is a LCO. So you are going to get the cathode of LiCO2. So we are going to get that. Now when the lithium ion is going to be transferred to the cathode, the reaction is going to be occur, and you are going to get the composition of LiCO2. During the charging, as we are going to provide the external energy source, that lithium carbonate is going to get lithium LCO2 is going to be get dissociated, and again the lithium is going to be get formed, and that is going to be transferred to the graphite. Any doubt in that chemical reaction? Hello?
No, sir. Go ahead, sir.
Okay. Now, if you are, as you are going to say, there is no reaction, but you have to concentrate on that, because when you are going to say that we are going to use the recent advancement into it, when you are going to say the recent advances, that means you should know the limitation. What is are the limitation? As you are going to check out the screen, there is a simple reaction is going to be there. During discharge, LiC6 is going to get converted to the C6, and lithium ion is going to be get generated. That is going to be occur on the anode. That lithium is going to be transferred to the cathode, and the reaction is going to be occur. Now the question is that when we are going to say the advancement in the lithium ion technology, what are the advancement are going to be occur? Now consider it is a 18650 cell. All of you are familiar. All of you are might be aware about the 18650 cell. that is the 18 mm diameter, 16 mm is the height, and it is the cell. Now, if you are going to consider the LFP, the nominal volt is the 3.2 volt. Now, when you are going to say the reaction is going to be occurred to generate the 3.2. Now, to generate the 3.2, we have to get the another thing. How you are going to get the 3.2 as the EMF? That EMF is the summation of the EMF generated at the cathode and the EMF generated at the anode. So 3.2, whatever the nominal voltage we are going to get, it is the summation of the EMF generated at the cathode plus EMF generated at the anode. So how much EMF is going to be generated at the cathode and how much EMF is going to generated at the anode, that should be known to each of us. Now, second thing, why we are going for the lithiated carbon? If you require the lithium as a source to carry out the reaction or to complete the reaction, you can go for the pure lithium, so that we can introduce the more amount of the lithium into the system, and you can go and get the maximum charge of it. Because when you are going to say that reaction is going to be occur, in the reaction the cathode anode is going to generate the negative. Electrons are going to be moved from the electrical source, and the lithium ion, which is a positive charge, is going to be moved through the electrolyte, through the separator, and it is going to be deposited on the cathode. So when it is going to be deposited on the cathode, then the circuit is going to be get completed and you are going to get the EMF. Now the question is that as the lithium is going to be get separated out from the anode and deposited on the cathode and to complete the cycle, then why we are not going to use the pure lithium as an anode material to complete the cycle? As we are going to use the pure lithium as a source of lithium, then your charge accumulation is on the higher side, so your charge generation is on the higher side. So as the charge generation is on the higher side, you can go for the higher power density. So why we are not going for that? Any idea on it? Why we have to go for the lithiated carbon? Lithiated, all of you are familiar with the lithiated carbon? What is the meaning of lithiated carbon? Hello? Whether are you familiar with the lithiated carbon? What is meant by lithiation? Hello? Okay. All of you are familiar with the diffusion? So, in the lithiated process, we are going to introduce the lithium ion into the graphite. Why? Because to carry out that reaction, you are going to require a certain amount of lithium, which is going to be generate the specific current density. Now, at the bottom, you are going to get an image of the cell, that is the 18650 cell. If you are going to check it out, at the end, there is a 3400 mAh. That means its capacity is to generate the 3.4 ampere. So, to generate that 3.4 ampere, how much lithium is going to be required? That much lithium is sufficient for that. So, to reduce down the weight of the cell, to reduce down the cost of the cell, we are going for the lithiated carbon procedure, so that we are going to release the amount of the lithium which is required to generate that 3.4 ampere hour in the circuit. Now when you are going to deal with the cathode material, why there is a change in the different types of cathode? Firstly, there is a lithium oxide, then we are going for the LFP, then we are going for the LTO, NMC, NCA. So many types of the cathodes are there. Why we are going to deal with the so many types of cathode? As the cathode elements is going to be changed, we are going to attract the pure lithium ion on the cathode to complete the charge with the effective one. Now, when you are going to release the lithium from the anode, when you are going to release the lithium from the anode, then there are the chances that lithium is going to be get suspended into the electrolyte, or it is going to be moved anywhere into the electrolyte. So, to move it from the anode to the cathode, we are going to use different types of cathode in such a way that lithium ion is going to be get attracted and deposited on the cathode. Clear? Hello? Hello? Okay, next slide. Now, the lithium ion cathodes. If you are going to check out the lithium ion cathodes, then there are the three types of structures are going to be available into the lithium ion cathode type. One is the layers structure, second one is the spinel structure, third one is the olivine structure. Generally, maximum R of us are going to have the layer structure. Then some of the cathode chemistry are going to consist of the spinel structure and then olivine structure. Just to move to the next slide. So you will get to know the type of the structure which are going to be there. LCO, NCA, NMC are generally deal with the layer-like structure. Then your LMO is going to deal with the spinel structure, and the LFP deals with the olivine structure. Okay. Next. Now, when you are going to say the structure, again, each structure has certain merits, each structure has certain demerits. When you are going to overcome those demerits, you are going to generate the advances into it. Now, just check it out the characteristics of the different cathode materials which we are going to be used in a practical use. So we have the LCO, NCA, NMC, LMO, and LFP on a chart. You can check it out the voltage generation, then specific capacity and specific energy. Okay, next slide. Next slide. Now lithium anode, or where which anodes we are going to be used into it. Generally, we are going to use the common carbon-based anodes, but right now the research is going to be carried out for the silicon-based anode in such a way that the lithiation of the lithium on the silicon is easily going to be carried out. And when you are going to release that lithium, then the dissociation and the deposition is easily going to be carried out. Then lithium ion electrolyte. Again, when you are going to deal with the electrolyte, then there are the number of electrolytes are going to be there. Again, when you are going to select the proper electrolyte for the lithium ion, again you have to concentrate on the flash point of the electrolyte. Why the flashpoint is going to become into the picture? Because during the reaction, the heat is going to be get generated. During the generation of the heat, the temperature of the electrolyte goes on increasing. As the temperature of the electrolyte goes on increasing, there are the chances that the conductivity of the electrolyte is goes on reducing. There is the unwanted, the reactions are going to be carried out into the electrolyte. So for that purpose, always the flash point of the electrolyte should be on the higher side. So for that purpose, the continuous research is going on to increase the flash point of the electrolyte. As we are going to say, the working temperature of the lithium ion battery is from the minus 15 to 60 degree. Out of that, when you are going to deal with the LFP, then it is 15 to 40 degrees centigrade. So for that purpose, we have to get the stable electrolyte to reduce down the temperature generation or to reduce down the temperature effect. So for that purpose, the electrolyte plays the major role into the cell. Next slide. This is the common hexa chart or the spider chart which we are going to be discuss or which you are easily going to be find out on the net. Just go through that hexa chart and let me know which battery you are going to be selected for the practical purpose. Okay. So out of that, out of this hexa chart, we are going to select the LFP currently with deal with the higher safety parameter, because you can bear any type of load, or you can bear any type of the loss which is going to be cause the loss into the money, loss into the service life of the battery, but you can't uh, recover the loss which is going to be occur where due to the battery on the human body. So for that purpose, safety is the prime concern. Next point, next slide. Now again, just check it out, the gravimetric energy density and volumetric energy density. Next, sulfur. As the lithium sulfur is the upcoming recent chemistry or upcoming advancement into the lithium ion battery technology. Just go through it. If you are going to check out the specific capacity and discharge capacity, then you will find out there is a tremendous change into it. So for that purpose, the sulfur is going to be have the attention. Next line, next. Now these are the few challenges and future work. In that we have to concentrate on the cost, specific energy, cold temperature performance and longevity of the cell. Next slide. We will discuss afterwards. Next slide. As now this slide onwards, we are going to deal with the advancement in the lithium ion technology. When you are going to say the advancement in the lithium ion technology, we know that in the lithium ion we have the anode, we have the cathode, we have the electrolyte. Now, when we are going to say that we have to make an advancement in the lithium ion technology, so when you are going to say the advancement, we have to concentrate on the specific energy and the energy density in such a way that in a small space or in a low weight, we are going to carry or we are going to get the maximum range per charge. So for that purpose, our main aim is going to be focus on that. So when you are going to find out this is our main aim, then we are going to find out which are the things which are going to be restrict ourselves to achieve that target. So for that purpose, we are going to start from the cathode. Why cathode? Now, if you are going to check out, then from LiLiO2 to the latest one, your anode is going to remain common and your cathode structure is going to be changed. We change the chemistry of the cathode. Then we are going to change the making pattern of it. Now in that we are going to deal with the different type of structure of the cathode. In that we already discussed that there are the layer structure, there are the olivine structure, and there is a spinel structure. Now, when you are going to say the layer structure, now what are the impact of the layer structure? Why we are going to why we have to think what are the points to be think from the layer structure? So these are the points which we have to think from the layer structure point of view. These are the some of the limitation. One is the capacity fading, voltage fade, thermal stability, oxygen release, then cycling rate limitation, voltage and capacity fade at high voltage, sensitivity to the surface contaminant, limitation of the energy density improvement, and the cobalt dependency. Now, what is meant by fading? All of you are familiar. Fading means your charge or something is going to be get deteriorated as per the cycle. So, in the case of capacity fading, when you are going to repeatedly charge and discharge the cycle, when you are going to discharge, you are going to transfer certain amount of the lithium ion from the anode to the cathode. So at that time you are going to send, suppose that is the 100 percentage of the lithium ion which are going to be transferred from the anode to the cathode. So on the cathode, some of the percentage are going to be dropped down. That means some of the lithium ion are going to be get suspended into the electrolyte, and 99 percentage is going to be deposited on the cathode. So you are going to get 1 percentage of the drop into the transformation of the lithium from the anode to the cathode. Now that when the discharging is going to be completed, you are going to get the 99 percentage of the lithium ion deposited on the cathode. Now when you are going for the charging, again you are going to dissociate it, that 99% with considering as it is a 100% lithium ion, and you are going to transfer that lithium ion from the cathode to the anode. Again there is a certain loss of the lithium ion is going to be occur. So that lithium ion either is going to be suspended into the electrolyte, or it is going to be make a bond with the cathode material or cathode surface, so that they are not going to be moved from the cathode to anode. So because of this, or because of such a repetitive reaction or repetitive cycle, the capacity of the cathode or the capacity of the cell goes on decreasing. Now, when it is suspended in the electrolyte, then it is going to be reduced down the efficiency of the electrolyte as the foreign particles are comes into the picture. Now, second thing, if it is going to be deposited on the cathode. Now, as we are going to deal with the layer structure means you are going to stack one above the other. Now, when the lithium is going to be deposited on it, it is going to be form the compound. As the energy fed up is on the higher side, it is going to form the compound. So, it is going to be attached with the surface. So, during that, there is a distortion or the lattice distortion is going to be occur on the cathode. Now, as the cycles is going to be continue for a longer period, so because of that, there is an expansion of the compound formation. As the compound formation goes on expanding, there is a distortion goes on increasing. As the lattice distortion goes on increasing, there is a cracking or crack is going to be initiated into the layer structure, and because of that, your total service life of that cathode goes on decreasing. Now, as the crack is going to be occur or the structure is going to be disorder, because of that, the voltage generation is also goes on reducing. That EMF generation is also goes on reducing, because as the lithium is going to be deposited on the cathode, that area is not going to take the part into the subsequent reaction. As it is not going to take the part into the subsequent reaction, it is going to remain inert, or it is going to be remain inactive in nature. So for that purpose, EMF generation is not going to be there. So EMF is also going to be fed. Now the thermal stability. What is meant by thermal stability? As we are going to give the charge to it, it is going to be generated the temperature at the cathode terminal. As the temperature goes on increasing, the as the temperature goes on increasing, the layer is again going to be get the instability due to the crack generation, due to the lattice distortion. As both of them are going to be come into the picture, your stability of the cathode gets deteriorated at the high temperature. As the stability gets deteriorated, your voltage fade is going to be caused, and your capacity is goes on reducing. Then spinel structure. Next slide, please. Now in the spinel also, the lower energy density, limited voltage window, rate capability, cycle stability, voltage fade, thermal stability, cobalt free operation, all those things are going to be come into the picture. Now, in the case of spinel, as we are going to deal with the structure, all of you are familiar with the atomic size of the lithium ion. All of you are familiar with the atomic size of the lithium ion? Okay. So that size is going to play the major role. Next slide. Olivine structure, again the same thing are going to be occur into the cathode, that as your lithium is going to be deposited, if it is not completely going to be taken out during the charge, the distortion of the cathode is going to be occur, even though whether it is a oxide layer, it is a layer structure, whether it is a spinel structure or whether it is a olivine structure, the structure is going to be get distorted. As the structure is going to be distorted, the capacity fading is going to be occur, voltage fading is going to be occur, as both are going to get fade, and as you are going to give the energy source, the temperature is going to be raised, that is again going to contribute to reduce down the capacity fading of the cell. Next. Huh. Now the common degrading mechanism. This is going to be occur into the lithium ion cell, whether you are going to deal with the LFP, whether you are going to deal with the NMC or LTO. These are the common things which are going to be formed. Might all of you might aware about the ACI formation which is going to be occur. So we will discuss one by one. These are the degradation mechanism. When you are going to overcome this degradation mechanism, you are going to get the advances into the lithium ion technology. So first one is the ACI formation. So next slide, sir. So just go through the image. So here you can check it out. It is a layer-like structure. Lithium is going to be come from the anode and it is going to be deposited on the cathode. So you can check it out on the top how the layer is going to be get distorted, how the compound is going to be formed. As the repeated cycles are going to be formed, this compound is going to be attached to the top surface of the cathode, and the ACI is going to be formed into the battery. Now, as the ACI layer is going to be formed, that solid electrolyte interface is going to be formed. Due to that, if you are going to check out this ACI, then there are the open surface into it, or open surface for the reaction is going to get detrimented, or it is goes on reduce. Because of that, the charge radiation is also goes on reducing. So for that purpose, we have to avoid the ACI formation into the cell. So just go through the image. Okay, any doubt about it? Just a second, sir. ACI. Any doubt about it? Now again, the formation of the ACI is not only the remaining of the lithium or the residual of the lithium on the cathode is the corresponding for the generation of the ACI. There are the number of parameters are going to be caused to form the ACI, which are going to be uh, which have to be think about it. When you are going to say the solid electrolyte interface, it is simply going to say that we are going to say that we are going to get the covering on the anode or cathode, and because of that the performance of the cell is goes on detrimented. But as we are going to keep it into the reaction, as in the started when we discuss the example of the Tata Nexon EV or EV Max, our range is too much high. We are going to utilize a small part of the energy throughout the day. So that is also going to be lead to the unwanted reaction which are going to be caused into the cell. That unwanted reaction is out of that unwanted reaction, ACI is one of them. Next slide. Lithium plating, it is going to be carried out on the negative electrode due to the preferential electrochemical reaction. Now, what is meant by plating? What is the difference between intercalation or lithiation and the plating? That you should know. All of you are familiar with the lithiation, or all of you are familiar with the difference between the lithiation and the poly plating, or the diffusion and the plating. Just think about that. If you are familiar with the difference between the diffusion and the plating, lithiation and the plating, then that is not a big deal to understand. We are going to use the anode as a lithiated carbon. As the lithiated carbon, we are going to forcefully introduce the lithium into the graphite. When we are going to forcefully introduce the lithium into the graphite, we are going to try to keep the lithium ion into the interatomic molecules of the carbon, but it is in the free form. But when the plating is going to be occur, it is going to be occur on the surface. It is going to be occur due to the formation of the compound with the surface. So for that purpose, lithiation is a different and the plating is different. Plating is going to be occur due to the compound formation, and when the compound is going to be formed, you have to break that compound to get the free lithium, and to break that compound you have to provide the external energy which is more than the energy required to move the lithium which is in the free form. Okay, all of you are getting it? Hello. Next slide. Then binder decomposition, current collector corrosion, electrolyte decomposition. What is meant by binder decomposition and where you are going to play the binder decomposition? When you are going to say that we are going to generate the LCO. How you are going to generate the LCO? Because lithium is having the different characteristics, cobalt have the different characteristics, or oxides of the cobalt have the different characteristics. So how you are going to make a single compound of it? So to make that compound, we are or all of you are familiar how you are going to generate the anode and the cathode. Manufacturing of the anode and cathode. During the manufacturing process of the anode and cathode, we are going to make a slurry. All of you are familiar with the slurry. Slurry is a mixture of the solid particle. Now, when you are going to say the solid particles, it is a solid is a physical nature. Now, when you are going to make a mixture, then it is also going to remain in a solid nature. So, to give any specific shape, you have to mix the binder, you have to mix the solvent or the carrier into it, and then you have to apply the pressure to make either anode or to make a cathode. So slurry is a semi-liquid in which the binder, carrier, and the our refractory materials are going to be there. Then that slurry is going to be what you say. We are going to put it into the required shape. We are going to heat in such a that solvent are going to be get vaporized and binders are going to bind the two different refractory materials with each other. Now, when we are going to say that AC is going to be formed or the plating is going to be formed, because of that, the thermal stresses are going to be occur. What is meant by thermal stresses? The fluctuation in the temperature is going to be occur. Because of that, mechanical stress is going to be get induced, as the mechanical stress is goes on inducing with respect to the temperature. As all of us knows that as the temperature goes on increasing, the expansion is going to be occur, and when the temperature goes on reducing, the contraction is going to be occur. And because of that such a cyclic loading, the binder is going to be get reduced down, or binder is going to be get what you say, is going to be moved from its mean position. So we are going to say the binder decomposition is going to be occur because of the high temperature and the mechanical stress. Then the current collector corrosion. Now, when you are going to say the current collector corrosion, then at the anode side and at the cathode side, we are going to use a plate which is going to carry the charges. Now, when you are going to say the current collector, at the cathode side, we are generally going to use the copper, and on the anode side, we are generally going to use the aluminium. So, at a higher voltage potential, copper is going to be get dissolved, and as the copper is going to be get dissolved, the impurities are going to become into the electrolyte, and because of that, the ACI layer is going to be formed with a higher rate. So for that purpose, we have to avoid that dissolution of the current collector. Then electrolyte decomposition, as the temperature is goes on changing, as the lithium is going to be get deposited into the electrolyte, as the ACI is going to be formed, the electrolyte is going to be get decomposed as decomposed, and as the electrolyte is going to be decomposed, your total performance is goes on reducing. Okay, any doubt up to this point? Any doubt? Okay, next slide. Okay. Then metal oxide positive electrode decomposition. Now, just go through the images. Now, on the cathode side, when you are going to deal with the different types of oxides are going to be there, they are going to be decomposed. As they are going to be decomposed, the mechanical stress is going to be carried out. Because of that, the you can check it out that all the effect is going to be come into the picture. Now, when you are going to say that decomposition of the metal oxide is going to be occur, when you are going to say the decomposition of the oxide, the gas is going to be
For
formed.
each 20 students, we will have one faculty who will be blessing your learning. All your
Yes,
details
anyone
provided
want to
your
ask a
attention,
question?
marks, whatever, will be communicated to your parents, to your learner. And whatever your communication, whatever problems you are facing as a student, it will be personal, it will be related to your college life, anything. You can share it with your parents.
Okay. So in the metal oxide, the during the because of the decomposition, disordering of the cathode is going to be occur. As the disorder of the cathode is going to be occur, the lattice is going to be get unstable in nature. After that lattice instability, the dissolution of the respective compound is going to be occur, and which is going to be corresponds to the surface effect on the cathode. So next slide, please. So here is the mechanism of the metal oxide decomposition. Four stages are going to be there. Disordering, lattice instability, dissolution of the metal oxide is going to be occur. Now when you are going to say the decomposition, if you are going to say the which example is there, LiNiO2 is, just go through the slide. Now, when you are going to say the metal oxide decomposition, LiCoO2, as due to the repetitive cycle, as the lithium is going to be get the amount of the lithium which is going to be transferred from the anode to cathode, and cathode to anode is going to be suppressed, or it is goes on reducing. The total demand of the lithium ion is on the higher side, and the available lithium is on the lower side. So to compensate that, the lithium which is present on the cathode is going to be take care, or it is going to be taken part into that reaction. So for that purpose, from the cathode, the lithium is going to be get separate out into the electrolyte to complete the cycle, to complete the charge production. So for that purpose, the decomposition is going to be occur. Now, when you are going to replace the lithium, then as the LiCoO2, and from that Li is going to be come out, then whatever the compound is going to be there, it is unstable in nature. To get the stability, they are going to be formed, or they are going to be try to react with each other or with another element. So because of that, there is a distortion is going to be occur, or there is a lattice instability is going to be occur. Now, to reduce down that instability, to reduce down that disorder, we are going to dope the cathode with the foreign element such as aluminum or cobalt, in such a way that the stability of the cathode is going to be maintained, and the distortion is goes on reducing. Next slide. Then ACI fracture and the reformation. As we already discussed, the ACI formation is going to be occur, but as you are but after a specific number of cycles, when your capacity is going to be fed, your voltage is going to be fed, and your demand of the charge is on the higher side. Because of that, there is a thermal stress, or there is a stress which is going to be generated on the anode and cathode. Or when the ACI is going to be formed, it is going to be formed on the top layer of the anode and cathode. In between that, there is a lithium ion which is going to be present in middle of that anode. He is trying to escape it out from that anode to the electrolyte. So for that purpose, the ACI is going to be get cracked during the repetitive cycling of the charging and discharging. Then particle fracture, again, as the ACI is going to be get crack out, the top surface of the anode and cathode is going to get uh, distorted, and it is going to be loose out from the its mean position because of the decomposition of the binder, because of the high pressure generated by the lithium, because of the gas evolution is going to be occur on the surface of the anode and cathode. There are too many parameters are going to be there which cause the release of the particle from its mean position. Then electrode displacement and the fracture. This overall results into the displacement of the electrode. Now, when you are going to say the displacement in our general layman technology, we are going to say it is going to be moved from its mean position to somewhere else. But when you are going to say the displacement of the electrode, that means there is a minor change in its size, shape. That is also called as a displacement of the electrode. So for that purpose, all those things are going to be result into the displacement of the electrode, and because of that, the impact on the performance of the lithium ion battery is going to be occur. Okay. Up to this point, we discussed the construction, type of the cell, general characteristics. Then we discuss the classification of the battery. Then we discuss the secondary batteries. Then that we discuss the chemical reaction. Then we discuss the lithium ion. In that lithium ion, we discuss the lithium cathode, anode, electrolyte. Then we discuss the general degradation mechanism. Then we discuss the problems related with the layer structure, olivine structure, and the spinel structure. Now we are going to be moved to the next part, which is the advancement into the lithium-ion battery technology. Okay, next slide. Patil sir, whether we have the sufficient time, because it's already 12:05. I am running 15 minutes late.
Yes, sir. Yes, sir. Go ahead, sir.
Okay. Just a minute. So, so no, sir. Last slide only. Last slide only. So there are the seven ways are there where the advancement of the lithium ion. No, sir. Next slide. Seven. Sir, last slide. Those seven types of the advancement in the lithium ion stage. Huh. So these are we are moving back. Next slide. Sir.
This one, sir.
Next slide, sir. This one. So these are the seven advancement which we are going to discuss if our time permits. Now in that there is a high nickel cathode, there is a solid state battery, there is a lithium sulfur batteries. As we already discussed that if you are going to deal with the sulfur, how the specific capacity and the energy density goes on increasing. So for that purpose, lithium sulfur plays the major role. Then we are going to deal with the lithium air, lithium silicon, and the lithium metal batteries. Now, when we are going to deal with this, why we have to move? We already discussed that we are going to be moved from the cathode point of view in such a way that whatever the lithium which is going to be generated or the release from the anode has to be received at the cathode end. So for that purpose, it shows that just a second. Am I audible?
Yes, sir.
Okay. So high nickel cathode. Now when you are going to say the cathode, we already discussed the layer structure, olivine structure and spinel. Out of that layer structure is going to give you the better performance over the spinel and olivine. And it is easy to manufacture. So for that purpose, we are going to concentrate on the high nickel cathode in such a way that nickel is going to give us the high energy density and the good rate capability. Next slide, sir. High nickel cathodes are popular owing to their high energy density and the good rate capability. You can check it out into the structure of a NFA. Nickel ensures the higher cell voltage and a continuous voltage profile, as well as the delocalized of the electron density, that is the good electronic conductivity. When you are going to employ the higher amount of nickel into the cathode, the capacity of the cell goes on increases drastically, but it comes along with the adverse effect that the thermal stability and long-term cycling performance goes on degraded. When you are going to say the residual lithium on the surface of a rich nickel atom is going to be there, and if it is going to be exposed to the air, then it is going to be cause the detrimental effect on the electrode slurry and its cyclability. Now when you are going to say the NFA, there is a formula LiNaix FeYAlZO2. In that XYZ is equal to 1 or XYZ is equal to 100%. Out of that, nickel percentage should be of more than 80%, then remaining of the iron and aluminium into the NFA. Okay, next slide. Now we will discuss about the solid state battery. There is a one video. Just go through that video. Sir, kindly play the video. Click on it, sir.
I think, sir, it's not working, sir.
Okay. Just a second, sir. Okay. Now I am taking the control, sir. I have problem might solve. Solid state battery. Just a second. Now, in the conventional lithium-ion battery, we discussed that there is a anode, there is a cathode, then current collector plates are going to be there on the anode side and on the cathode side, and in between that there is a separator. The work of the separator is to pass only the ions and restrict the electrons which are going to get generated. So, in the normal lithium-ion battery, when you are going to discharge, the lithium ion is going to be transferred from anode to the cathode, and during the charging from the cathode to the anode. Now, in the solid state battery, we are going for the advancement into it, and we are going to reduce down the separator. We are going to use a solid electrolyte as a separator, and the ions which are going to be present into the cathode while charging, they are going to be generate, or they are going to be make the pure lithium ion anode on the second side. So that is the major change into the solid state battery. So for that purpose, just go through the video, then we will start to discuss. Hopefully the voice of the video is audible.
Video voice is not audible, sir.
Audio is not audible.
Yes, sir.
No, sir.
Just a second. Okay. So now it is audible. Now it is audible.
Yes, sir.
Huh?
Yes, sir. So you can elaborate, sir, with your voice.
Yes.
You can elaborate the things with your voice, sir.
I didn't get you.
Sir, you can simultaneously explain the things, sir. We can understand that video also.
Okay, okay. No, just a minute. My methodology is that once you go through the video, we will replay it, and at that time I will discuss with you.
Okay.
Okay. Now we will discuss what is the video or what the video says. Now, when you are going to say the normal lithium ion batteries, this is your conventional lithium ion battery in which you have the anode, which is called shows as a black in nature, and the cathode white in nature. Then in between that you are going to get the polymer separator. On the top of side you are going to get the electrical contact as anode and cathode. Now, during the discharge, as we have already discussed that anode, it is generally the lithiated carbon. Lithiated carbon, we already discussed the chemical reaction or chemical formula that LiC6. LiC6 means 6 atoms of the carbon is going to be hold one lithium atom. So that means you are going to take, if you are going to take the 7 atoms of out of that 7 atoms, 6 atoms of the carbon and 1 atom of the lithium. Now, when the reaction is going to be occur from the anode, the lithium is going to be separate or it is going to be transferred from the anode through separator to the cathode to complete the reaction. Now, during that, the movement, the carbon is going to remain the stationary at that location as you are going to carry the carbon as a stationary which is not going to take the part into it, but because of that the weight of the battery goes on increasing. So to reduce down that weight to such a way that energy per weight or the energy per weight of point to be increased, so for that purpose we are going to deal with the solid state battery. Now in the solid state battery we are going to, and again we discussed that the size of the lithium ion, the size of the lithium ion is on the in such a way that it is easily going to be placed interatomically in between the two atoms. So for that purpose they are easily going to be moved in and out throughout the matrix or throughout the lattice. So for that purpose, in the solid state battery, we are going to consist of the cathode. That in that cathode, the lithium ion is situated in an interatomic position. There are the substitutional and interstitial solid solution in such a way that the lithium ion is going to be placed interstitially in between the two atoms in such a way that where volume is goes on reducing and the weight of the carbon is goes on reducing. So while the charging, cathode is going to release the lithium ion. So while the charging, when the cathode is going to release the lithium, that lithium is going to be separate out or it is going to be get collected across the separator, which is the solid electrolyte or solid composite, ceramic composite. On the second part of the solid ceramic separator, we are going to get the lithium, which act as a pure anode into the condition, and while the discharging, that anode is going to discharge all the lithium and all that lithium is going to be transferred to the cathode to complete the cycle. So just go through the video once again. So this is the conventional lithium ion battery. In anode we have the LiC6, that is the lithium lithiated carbon. So during the discharge reaction, now it is a cathode one. So during the charge, so during the charge, the lithium ion is going to be removed from that NMC or that from the cathode. It is moved from the separator and again it is going to be moved to the anode, that is the lithium carbon. So it is going to be moved interstitially. You can check it out. 6 carbon atoms are surrounded one lithium. So it is interstitially situated. So because of that, we are moving for the solid state. So on the top, we are not going to get the anode. We are going to get only cathode. In that cathode, the carbon, the lithium is interstitially situated. So during charging, again the lithium, which is interstitially situated into the cathode, it is going to be get separate out and it is going to be moved through the solid state ceramic separator and it is going to be form the anode. Whatever the percentage of the lithium is going to be separate out from the cathode, all is going to be contributed to form the lithium metal anode on the second side. And after the complete charging, you are going to get a sufficient thickness of the lithium metal anode which act as a pure anode material for the discharge. So during the discharge, again this anode is going to be dissociated, electron is going to be moved from the external circuit and the lithium ion is going to be moved through the separator to the cathode. Sorry. Now, what is the impact of it? Why we have to go for that? Because if you are going to check it out, then your volume is goes on reducing nearly by 60%. Then your weight of the carbon, which is going to be act as only as a carrier to keep the lithium into the anode, is also goes on reducing. So your weight and your volume goes on reducing. As your weight and volume goes on reducing within a constrained space, your energy density goes on increasing. So for that purpose, solid state have the carry the more attention in a research. So solid state battery. A solid state battery with solid electrolyte shows the improved stability with a solid structure and increased safety since it maintains the form even if the electrolyte is damaged. Now, when you are going to say the solid, liquid, gas, all are the physical states of the any material. So when you are going to say the solid part, then whenever the heat is going to be get generated, then that heat is easily going to be absorbed by the solid and then it going to be transferred to the liquid phase. But when you are going to say the liquid electrolyte and heat is going to be occur, then as the flashpoint is going to be occur, the gas evolution is going to be occur. So that gas evolution is drastically goes on reducing in case of solid state electrolyte. A solid state battery has higher energy density as we already discussed. It doesn't have a risk of explosion or the fire. So there is no need to have components for the safety, thus saving more space. Then we have more space to put more active materials which increase the battery capacity in the battery so that you can increase the size of the cathode. How it works, we already discussed. Just a differentiation between the conventional and the solid one. Just go through it. Okay. It therefore becomes the medium through which the ions move. That is your solid state separator and also has electric insulating property and as a mechanical separator between the anode and cathode. So this is the working of the solid state. Then lithium sulfur battery. Lithium sulfur battery technology currently under development and shows the extremely high specific energy. Theoretic specific energy is approximately 2500 watt hour per kg. Although it is not nearly ready for the commercial production, primarily due to the cycle life and the safety concern. It has demonstrated its basic performance and the energy density potential in niche application. The basic cell is comprised of a self cathode, generally supported with a porous carbon framework, a liquid electrolyte, and a lithium metal anode. These are the following reactions. Just go through it. Okay. Throughout the presentation, we didn't discuss about the porous nature. I think all of you are familiar with the porous nature. Porous nature means we have the higher permeability or gases can be passed throughout it. So generally we are going for the porous nature of the anode and cathode. Why we are going for the porous nature? As first of the reason, lithium metal or the lithium ion are having the lower dimension, so it can be easily going to be penetrated through it. Second, because of the porous nature, your surface area goes on increasing. As your surface area goes on increasing, the reaction area or the reaction surface goes on increasing, which is corresponds to or which is respond to the higher charge accumulation which is necessary from the discharge point of view. So for that purpose, we are going to deal with the porous nature of the anode and the cathode. Okay. Then the challenges and future work of the lithium sulfide battery. The promise of a practical specific energy that is at least twice that of the lithium ion battery. Much more work remains to be done from the capacity fade, self discharge, and safety point of view. So these are the certain challenges and future works to be carried out in the lithium sulfide battery. Okay, so that's the end of the presentation. Now the forum is open for the discussion. There is a contact if you want to discuss anything in personal. I am always open up for the same. So feel free to discuss. Yes, anything? Question?
So,
Ah,
so what if lithium sulfur battery comes in picture? It may be change the battery size of the battery size and capacity range of EV and the scenario will change, sir, no?
yes. When you are going to say the capacity of the lithium sulfate is approximately 2500 watt hour per kg, that means your size is drastically goes on reducing. Right now, whenever we are going to use the lithium ion battery currently in the market, available in the market, just check it out. If you are going to deal with the LFP, it have the 170 and it is 1675. That means 10 times more. So if it is a 10 times more, that means your 10 times size reduction is going to be occur. If you are going to say the discharge capacity, then it is at nearly about twice. So for that purpose, size of the battery goes on reducing when you are going for the advancement in the lithium ion battery technology. Yes, anyone else?
This may boost the range of EV vehicles and maybe it will be more compatible to the IC engine, right? Sir?
You can't compare directly with the IC engine because IC engine is a different story. Because in case of IC engine, when you are going to say the IC engine, you are going to get the petrol pump or fuel pump at a certain instant. So for that purpose, you are going to not going to think from the range point of view. But when you are going to deal with the EV, you have to deal from the kilometer per charge point of view. And when you are going for the advancement, right now also we are going to deal with a higher kilometer within a single charge. But on the secondary story, as I already discussed here at the start, EV Max, Tata Nexon EV Max come up with the 400 kilometer per charge. Too many vehicles are coming with a 400 kilometer per charge. Whether you are going to utilize that much on a daily basis. That is one of the thing. Again, the at the time of selection of the battery, at the time of selection of the capacity, you have to think from that aspect. The window is open, but how much, or there is a capacity to increase, but how much to take, it is again the choice of a designer, it is again a choice of a customer. Okay.
Yes, sir. Yes, sir.
Or second one, I will give the second one. All of you are familiar with the MG Comet. It comes with a range of 230 km per charge. It is specifically carried out, or it is specifically designed for the urban use, for a daily use. That means I am going for the work which is 20 km apart. So daily 40 km or 50 km. So within a 1 week I am going to charge. If you are going to take the Nexon for a 20 days, same application, then your charging time goes on increasing, which is again going to be caused to fade up your battery performance. If you are not going to utilize the battery on a daily basis, then also your battery is going to be fade up. Hello.
Yes, sir. Sir, one another question from chat box. How thermal management is there, sir?
How?
Thermal management is there.
Now thermal management is again a one big challenge. Now when you are going to say the thermal management, heat is going to be generated. Now there are the two type of the heat we have to consider. One is the internal heat, one is the external heat. External heat is corresponds to the atmospheric temperature. But as we are going for the IP67, and as we are going to deal with the stringent, external heat is not going to play that much role toward the internal temperature of the battery. So the internal temperature of the battery is going to be caused due to the four reaction, as I already discussed: heat of polarization, heat of chemical reaction, heat of Joule's heat, and heat of discharge. So out of that, heat of this Joule's heat, I square R is the prominent way to generate the heat inside of it. So whenever you are going to deal with the BTMS, you have to concentrate on the how much heat is going to be generated by the each cell, then how many cells are going to be there in a one string, or how many cells are going to be there in a module, in such a way that we are going to control the heat generation into the module, and we are going to get the safer nature of the battery. Now, when you are going to say the safer nature of the battery, at that time, as I already discussed, that how you are going to find out the number of cell and number of the current, number of the module. Now, suppose as I right now discussed the EV Max, which you are going to get the 40 kWh battery. When you are going to deal with the 40 kWh battery, that is the power, or that is the energy with respect to the time. So just consider the power, that is the 40 kilowatt. Now to get the 40 kilowatt, power is equal to VI. So you have to concentrate on the V and you have to concentrate on the I. Just for an example, if it is a 40 kilowatt, that means 40,000. If I am going to select the 400 volt system, if I am going to select the 400 volt system, then the current is equal to 100 ampere. So whatever the Joule's heat is going to be generated, it is 100 square into the R, and the resistance or internal resistance is generally 0.002. So that is the heat is going to be generated. Now at the same time, if I am going to use the voltage system of 1000 voltage, then the current is the 40 ampere. So 40 square. If you are going to compare the 100 square and the 40 square, then the 40 square is value is on the lower side. So how you are going to select the voltage system, on that your I is going to be vary, as your Y is going to be vary, on that base you are going to deal with the BTMS, which is going to be implemented in it. Okay, hope I fulfill the demand of the Pundik sir.
Yes. Sir, another question, one general question is there from Deepa madam.
Okay.
That he is asking that there is a need to change battery after 5 to 6 years in two wheeler. So does it worth to buy two wheeler which cost above 1 lakhs? Your opinion.
Yeah. Deepa man, there are the two ways. If you are going to check it out, when you are going to say that my battery life is 5 to 6 years, whenever you are going to take the battery, it is not going to become as per the life of as per the years life. It is going to become 3000 cycle, 2000 cycle. In that fashion, we are going to deal with the battery life. Now, when you are going to say the 5 to 6 years battery life for the two wheeler, now as I just now told you that if my range is 430 and how much I am going to use. Now, what is the meaning of the one cycle? When you are going to charge, if your battery is 100% charged, then you are going to discharge up to 20%, and again you are going to charge up to the 90%. That is called as a one cycle. So it is gives you the 3000 cycle. Now, if you are going to carry out once charging of a battery a day, that means a cycle is going to be carried out a day. So if it is a 3000 cycle, then it is nearly about the 9000 cycle, 9000 days. Sorry, 3000 divided by 365. So 9 years are generally going to be give as a theoretical calculation. But meanwhile, we are not going to utilize as the drain up to the 20% balance, and we are going to charge up to the 90% balance. Because of that, the capacity is going to be fed up. If you are going to calculate the kilometer which you are going to be drive in this 5 to 6 years, then you will find out on an average whatever the whatever the cost which I am going to be taken out from the petrol, our cost of the battery is going to be get fulfilled within 3 to 4 years only. If your utilization is on the lower side, then you are might be thinking that where I'm investing or I'm dead in my dead investment is there on the battery side. But your regular use is on the higher side, then it is not the dead investment. It is a bright investment into the battery. Hope Deepa ma'am, give the better answer.
Yes, sir. Sir, last question. What are the advances in technology in thermal management, sir?
In thermal management, again, as we are going to deal with it, there are the thermal management of the battery. So we have to check out the heat generation. As I have told you that there are the fold reaction, and out of that, joule heat is the major. As your current goes on increasing. Now, when you are going to say the electric vehicles, from the bicycle to the truck, all the varieties are going to be come into the picture. When you are going to deal with the bicycle, current withdrawal is on the lower side. Two-wheeler current withdrawal is on the lower side. So for that purpose, for the bicycle and two-wheeler, you are not going to get any type of thermal cycle, thermal management system in a practical. But for the four-wheeler and above that, we require the thermal management system. Now in the thermal management system, we are going to deal with the air cooled, we are going to deal with the liquid cooled, we are dealing with the PCM cooled, and now we are going to deal with the nanofluid introduced into the liquid. So these are the advances are goes on increasing. Now when you are going to select any material or any fluid as a media, then you have to check out the latent heat of that media in such a way that heat extraction rate is going to be there. Again, when you are going to deal with the BTMS, as I told you that you have to finalize your voltage system. As you are going to increase your voltage system, the current generation is on the lower side. As the current generation is on the lower side, then you can go for the liquid cooling. In that liquid cooling, ethylene glycol is currently going to be used by the various OEMs in their BTMS. If other than that, if your the current is on the higher side, heat is generated on the higher side, then the water-based nanofluids are going to become into the market soon. Okay, Kundlik sir.
Yes.
Anything else?
Still, any question will be there? Can you ask? Participant can ask directly to the sir. Sir, sir. Okay. I hope sir doubts are clear, sir, right now.
Okay.
So it's time to give the vote of thanks, sir.
Just a
So,
second. Just a
yes, yes.
second. Thank you, organizer, for giving me the opportunity to express my experience. Thank you, all the participants, for the uh, patientful listening, and sorry for the technical glitch occur meanwhile the session. I'm really sorry for that. I'm open up for the discussion. So kindly note down my number and mail ID. If any discussion you have to carry out in the future, then I will be happy to share it or to discuss it. So thank
So
you once again.
Sachin sir asking about that. Is there any? Please comment on testing, sir. What I don't understand, but he asking about testing, sir.
Battery testing.
Couldn't understand, sir, but please comment on testing. Only write that thing, Sachin. Sachin, sir, can you elaborate that thing? What you want to ask?
Okay.
Sir,
Hello,
another
sir.
question, Deepak is asking that is there any company for student industry visit of students, sir, in Pune area?
Deepa ma'am, I'm not from the industry. I'm from the academician, MIT Aditi University. If you want to visit to my lab, you can. In my lab, you have from the cycle to four wheeler, all the skirt section of the cycle, too many parts of the electric vehicle powertrain. We have the softwares, we have the testing equipments from the cell to the battery, from the motor. So for that purpose, if you want to visit, then you can visit. You can contact me. We can arrange a visit for you.
So, respected guest of today's program, Professor Sasank Gowde, sir, respected Principal Dr. Suhas Khoth, sir, Professor Gayatri S. Patil, Head of Mechanical Engineering Department, and my dear colleague and participant. It seems to be great honor to propose a vote of thanks to all who have helped us in making this session successful. I would like to thank our today's session speaker, Professor Sasan Gowde sir, for making an excellent presentation and making this session very meaningful and interesting by giving real-time examples and focusing on question answer and everything. Sir have covered many topics like introduction of battery, construction, recent advancement in lithium-ion battery technology, state of charge, battery classification, charging and discharging of battery, reaction of different types of battery, lithium-ion electrolytes, lithium-ion challenges in future work, spinels, olivines structure, common degradation mechanism in lithium ion cell, lithium plating, metal oxide positive electrode decomposition, lithium nickel cathode, solid state battery, lithium sulfur batteries. I would like to express our deep gratitude to KGI management for continuous support, our respected principal Dr. Swaz Khoth sir for his continuous motivation, FDP coordinator Professor Gopal Patil sir and Vidyadhar Dikshit sir. I am happy to express a vote of thanks to our participants who made this FDP successful through their presence and patience. Last but not the least, I thankful to all faculty of Mechanical Engineering Department who helped directly or indirectly for this FDP. Once again, I thank you all for your cooperation. Thank you. Have a great day ahead. Thank you, everyone. Thank you so much, sir.
Thank you.
Thank you, sir.
Thank you, Shashank sir.
Thank you, Gopal sir, for giving me the opportunity.